question, we have three geometric terms, 2p plus 6 minus 2p and p plus 2, where p is positive. We have to find the sum of infinity of the progression. Now, what we know about the common ratio of a geometric progression is that to find the common ratio, we divide two consecutive terms together, meaning we can divide the second term by the first term, or R could also be the third term divided by the second term, or it could also be the fourth term divided by the third term. What we need to understand is that it will always be two consecutive terms that are dividing with each other. Now we know that the second term is minus 2p, so we can write R is equals to minus 2p divided by the first term, which is 2p plus 6, and R can also be written as the third term, which is p plus 2 divided by minus 2p, which is the second term. Now, as it is a single geometric progression, the common ratio must be the same, so we can equate these two equations and find the value of p. So solving this, we get minus 2p into minus 2p, which is 4p squared. 2p plus 6 multiplied by p plus 2 would become 2p squared plus 4p plus 6p plus 12. Simplifying this, we get, so 4p square minus 2p square is 2p square. 4p plus 6p is 10p, so this will become minus 10p minus 12 is equals to 0. We can write it as p square minus 5p minus 6 is equals to 0. Factorizing it and solving it, we get p minus 6 and p plus 1 is equals to 0. So the two values of p are p is equals to 6 and p is equals to minus 1. Now, as p has to be positive, so this is the value of p that we will be taking for the next part, which is finding the sum of infinity. Now, the formula for the sum to infinity is a divided by 1 minus r. So a is the first term and r is a common ratio. So we know that a is equals to 2p plus 6. So a is equals to 2p plus 6. Taking p is equals to 6, we get a is equals to 18. 2 times 6, 12 plus 6, 18. The common ratio can be taken as minus 2p divided by 2p plus 6. Substituting 6 into the equation, we get minus 12 upon 18, which makes r is equals to minus 2 upon 3. Now, substituting these values into the formula for sum to infinity, we get a is equals to 18 divided by 1 minus 2 upon 3. Simplifying this, we get 18 divided by 1 plus 2 upon 3, which is 5 upon 3. And simplifying this, we get 18 multiplied by 3 upon 5, which is 54 upon 5. Or we can give it as 10.8. So this is a sum to infinity of the geometric progression.